You should have spotted the mistake already. You know how to do this type of problem, right? Let's call the top step number. You want to call it A? You want to use the alphabet or the numbers? Let's try alphabet. We don't use we yeah. So line A, B, C, D, 5, or 6. We'll compromise. On what line, if any, does this student make a mistake? When I say if any, that's mathematical foreshadowing. It means he may not have made a mistake. B. It's B. What did he forget to do, Emerson? Yeah. We got to isolate the radical if we can. We learned that yesterday we can't always isolate the radical. Sometimes we can because there's two radicals and one goes on each side. But in this case, there's only one radical. So what this fellow should have done is divided through by the 2 first and gotten 12 divided by 2, which is 6, right? Now let's finish out the problem, shall we? He would get 6 instead of 12, and then he would square both sides, and you get 3x plus 3 equals 36, and that means 3x equals 33, and x equals 11. And I guess it has to work, doesn't it? No, we don't even, no, Emerson, no. We don't even know if he, when he got 23, even checked his answer, right? So we could have had a 7th check down here where it's check yourself before you wreck yourself, right? I don't think he checked himself, so he would have found out he did something wrong. Let's plug in an 11 right here. Right there. 11 times 3 is 33. 3 plus 3 is 36. The square root of 36 is 6. 6 times 2 is? It works. It works. So that's the real answer. Now, there's another way we could have fixed this. Instead of dividing by 2 first, I wouldn't have done it, but we could have squared both sides with the 2 remaining on the left side. We just would have had to have squared the 2 as well. Remember that? Yeah, and that would be a 4 right here instead of a 2, and then you can work straight down and you'll get the right answer eventually. You just have bigger numbers to work with, like 144. So keep the numbers small, right? Try to isolate the radical if you can. If you can't, like over here on example 2, whatever it was, try to use whole numbers like 2 instead of rational fractionals like that. Rational fractional numbers like 1/2. Okay. The last thing I want to do is a challenge problem. If you've ever done these on the test, these are where the bonus on the test usually come in. Bonus on test. And if you've ever gotten them right, you know they're worth plus 50 points on the exam, right? Just kidding. Just kidding. Yeah, I wish, right? Yeah, then everyone would go straight to the bonus, right? They're worth usually 5 points. And sometimes you can get up to 10 points bonus because there's more than one. All right, so I see 2 radicals, no problem. So I can isolate the radicals. So let's bring the negative guy over, and we get the cube root of 2x equals the square root of 3x. Now, the problem is, even though we got them isolated, do I cube both sides or square both sides or something? Well, if I do them individually, whatever I do to one side, I got to do the other. So I can't just cube that side and square that side. That doesn't work, does it? Whatever I do to one side, I got to do the other. So I could cube both sides, and that'll get rid of the radical on the left, but it doesn't get rid of, what am I trying to say? It doesn't get rid of the radical on the right. Yeah, so if you want to try and square it instead, we can square both sides, and that'll get rid of the radical on the right, but it won't get rid of the radical on the left. So what to do? Well, let's think of it in terms of fractional exponents. This is really 2x to the what power? 1/3. And this is really 3x to the what power? 1/2. And remember, notice I put the parentheses around it. It's a quantity. Let's come over here and think about algebra 1. Maybe algebra 1. If you had 1/3 x equals 1/2 x, what could you multiply both sides by to get rid of the fraction in one step? I heard it whispered. Could I multiply both sides by 6 to do the trick? Yeah, because 6/3 is 2, I get 2x, and 6/2 is 3, I get 3x. So what is 6 when you're talking about the numbers 2 and 3? It's what? It's not the greatest common factor. It's their least common, yeah, denominator or multiple, either one. Least common multiple or least common denominator. That's what we're going to do here. We're going to raise both sides to the 6th power. It's their LCM. We only call it the LCD when it's in the denominator. Otherwise, it's the LCM, least common multiple. So I get 2x to the 6 thirds, which is 2. And then I get 3x to the 6 halves, which is 3. And now I can expand it. 2 squared is 4, so I get 4x squared. 3 cubed is 27, so I get 27x cubed. Now we're kind of back on solid ground again, right? But here's what you cannot do. You cannot divide both sides by x squared. That doesn't work. What you do instead is you get everything on one side. And I'm going to get everything on the right-hand side just because the x cubed is over there. And that gives me minus 4x squared. Now, anytime we have something equal to 0 in this class, we've always attempted to what it on the next step? Double bubble. Yeah, double bubble. Which double bubble is a form of factoring, right? But the first rule of factoring before we double bubble, because that doesn't work here, is to pull out a common factor. Is there any number that's common between 4 and 27? Nothing common number-wise, but what about x-wise? We got a common factor of x squared. So if I factor the x squared out, I get 27x minus 4. And now I can set them both equal to 0. So either x squared equals 0 or 27x minus 4 equals 0. And that means x equals 0 or x equals 4/27. Woo! You box them both up and walk away if you're looking for bonus points on the test. This could be like a 10-pointer on a test. Maybe not a 50-pointer, but maybe a 10-pointer. Or is there something else we need to do? Yeah, we better check ourselves before we wreck ourselves. All right, so we got to try the 0 and we got to try the 4/27. Ooh, yucky, yucky, gross, gross. Which one do you want to try first? 0 is going to be easier to try out. You can set it on my desk. 0 is going to be easy to try out. 4/27 is going to be more challenging to try out. You want to start easy and end challenging, or start challenging and end easy?
Start challenging and end easy.
I'd rather do that too. Yeah, let's do 4/27. 4/27 times 2 is 8/27. 8/27. The cube root of 8/27 is the cube root of 8 over the cube root of 27, which is what? 2 over 3. So it works out nicely. This is 2 over 3, or this is 2 over 3. Okay, you can actually plug it into this line as well because we haven't changed anything. So we get 2 over 3 on this side. Let's plug it in here. 4/27 times 3 is 12/27. 12/27. Is the square root of 12/27 a nice number? That's the square root of 12 over the square root of 27.
No.
Neither one of those are perfect squares, so it's not going to be an integer, is it? So are they equal to each other? Because they're only 0 when you subtract them if they're equal to each other. Are they equal to each other? No. So the 4/27 doesn't work. All that work to get a funky number that doesn't work, what do we call that guy? He's extraneous, right? He is so extra. Ugh. Let's try the 0. 2 times 0 is 0. The cube root of 0 is 0. Minus 3 times 0 is 0. The square root of 0 is 0. What's 0 minus 0? 0. 0 works. How anticlimactic is that? 0 ends up working. So we'll just finish off the week, I should say, by crossing this out and saying this one is extraneous, and then leaving the other one visible, and there's our answer. Yeah, that's it. That's the whole section. There are some questions for reflection here, which you could spend the rest of the period stroking your chin as you ponder these questions, which I am not going to go over because I'm not going to ponder for you. I'm not going to come stroke your chin for you. And the answers are given off to the side in red, so you can test yourself if you want. Okay? So if you want to read through that, you can. Otherwise, you have the rest of the period to work on 12.3. 12.3. Okay? Any questions? I think I told my third period and my fifth period that section 12.3 was going to be due at 4:20. So rather than have to make another announcement that I was wrong to them, I'll just extend that to y'all for whatever it's worth, okay? Whatever it's worth. But then on Monday in class, we have a chapter 12 review, and I'm going to let y'all work on that in class. Chapter 12 review, which is going to be due on Tuesday at 9 a.m. All right. So I guess technically in class, you on Monday you can either work on the review or 12.3 or both, because I'll make 12.3 due in the afternoon. But we are quizzing on Tuesday. So if you're not here Monday because you're sick with solar fever, and you come back Tuesday, unless you have like blisters from your sunburn and your eyes are like popped out of your head because you stared without glasses, you should be ready to take the quiz on chapter 12. It's the whole chapter, 1, 2, and sections 1, 2, and 3. Okay? Sound good? Sound bueno? All right. So I'm here if you need me. You can ask me any question, math or solar related. I will try to answer it. Otherwise, you can plug in your earbuds now and get in your own happy math zone. Be productive. Be productive on a Friday afternoon. If you're here, you might as well be productive and have fun. All right, I'm